Okay, on number 5. Actually, before we start, who can tell me the difference between estimating and rounding? What is the difference between estimating and rounding? Maya?
Estimating is getting close to the actual answer. Rounding is...
Okay, so estimating, you're actually getting to an answer, and you're getting close to the actual answer. So what is rounding? So?
Rounding the answer.
Okay, you can round an answer, or could you round each number in the problem? Yes, you are changing each individual number and rounding it to a specific digit, okay, to a specific place. Are they similar? Yes, okay, but they are not the same. Estimating, you're actually finding an answer close to the actual. So, number 5. Oops. Abby, what did you round the problem to?
So for 4.62.
$4.62. What did you round that to?
I round that to $5.
$5. So you had 4 times 5, and what did you get?
20.
20. So 4 times 462 is about $20. Number 3, Sadie, what did you round it to?
I rounded 23.07 to 23.
Okay.
And then I kept the 3 the same. And then I got 60.
Okay, because then what did you do?
Because I turned the 23 into 20.
Okay, because 23 times 3 may not be mental math. Raise your hand if you left it as 23. Did anybody? Okay, so most of you then changed it to 3 times 20. So either of those are fine. Okay, if you left it, it's fine. If you change it to 20, it is fine. Next one, 1550 times 6. Lori, what did you round it to?
I rounded it to 16 times 6.
Okay.
Then I got 120, but I rounded the 16 again to a 20.
Okay, so then she changed the 16 to 20 times 6 and got 120. Did anybody change it back down to 15?
Yes.
Okay, why are 15s aren't super easy to count by, but what helps us count by 15s? Does anybody know? Harper?
It has a 5 in it, and you should know. Oh, it goes up. Something.
30.
Brady?
Time on a clock.
The time on a clock, because if you count by 15 minutes, most of us can do that. 15, 30, 45, 60 is 4, and then build up from there. 2 more would be 75, what? 90. Okay, and again, if you can't do that, that's fine. I'm just trying to teach you tricks to help you with those more common numbers. Okay, so either of these are perfectly okay. Number, what, Parker?
What about 16 times 6?
Did you do it mentally with
Yes.
out to the side?
No, I didn't do it. I was just to the side.
What?
I didn't do it out to the side.
Then that's fine. Number 8, Kendall, what did you round it to?
I rounded 16.85 to 17,
Okay.
and then I changed the 17 to 20.
Okay, so she changed the 17 to 20 and got 180. Did anybody change the 9? What could I change the 9 to, Jude, and make it mental math?
You change the 9 to a 10.
Yeah, could I leave the 17 a 17 and make the 9 a 10 and get 170?
Mm-hmm.
Are both of those okay?
Yes.
Yes, because we're estimating. Okay, we're getting close to the actual, so both of these are perfectly okay. Questions about those 4? Maya, number 9. What'd you round to?
I changed the 17 to 7.
Okay.
The 5 the same, and I got 35.
Okay, 7 times 5 is 35, so 7.2 times 5 is about 35. Bryce, next one, what'd you do?
I changed to 4.5 to 15.
Okay. What's 15 times 3? 45. Okay. Brady, next one.
I rounded 9 times 19.7. I rounded 19.7 to 20.
Okay. So you got 180?
Mm-hmm.
Okay, good job. 12. Reese, what'd you do?
I did 11 times 26, and then I changed the 26 to a 30.
Okay.
And then got 330.
Okay, good job. Did anybody do that one different? Bryson, what did you do?
I changed the 11 to a 10 to get 260.
Okay, so you changed the 11 to a 10, the 26.2 to a 26, and got 260. Does his way work? Okay, Parker?
I just did it 11 times 26.
So Parker, you should,
That's 286.
okay, did you have to do that out to the side? And if you have to think about it, like, okay, 26 times 10 is 260, 26 times 1 is 26, 260 plus 26 is this. That's not quick, okay? So if I would say, Parker, what's 11 times 26? You'd say 286. No. Okay, we're rounding. We're not finding actuals, okay? Number 13, 89 cents times 14. Kaden, what did you round that to?
I rounded 0.89 to
1 times what?
14.
1 times 14 is what, Kaden? 14. 18.8 times 3. Finley, what'd you change that to?
I changed the 8 to a 9.
Okay, well, hold on. So you changed 18.8 to a 19 times 13, okay? Could you do that problem mentally?
No.
So what did you change it to?
20.
Times what? Okay, she did 20 times 10 and probably got 200. Did anybody do it different? Maya?
I did 20 times
Okay, because 2 times 13 is mental math. So is that one fine? Questions on that one? Okay, raise your hand if you if this is pretty easy. Okay, just like adding and subtracting, round it to the nearest whole number. Do the math, and then if you can't do the math mentally, then round it to a number that is compatible. Okay? Set your book aside, don't close it yet, and pull out that decimal operation rules paper. I just have to pull out a whiteboard because I don't have that on my screen. Okay, again, put your name at the top if it's not already there. I'm just going to divide my screen into 4. Okay, top left, it says add, and then there's a spot and it wants an example. Who thinks they can tell me the rule for adding decimal points? Maya? Okay, so if I just put line them up, okay, so you have to write small, line up the decimal points. What else do we have to do sometimes after we line up the decimal points? Lori?
If the decimal doesn't have the same number of digits as the other one, after the last digit, you add 0.
Okay, so we will add zeros. And in parentheses, all right, if needed, to make the numbers have the same number of decimal places. have to write kind of small. So line up the decimal points. Add zeros if needed to make the numbers have the same number of decimal places. How do we know where the decimal point in our answer is? How do I know where the decimal point in my answer is? Maya?
Where the decimal, you just drop it.
Yeah, so let's line up the decimal points all the way, I should have put this sooner, sorry, all the way to answer. Meaning you line it up. You should have at least 3 decimal points. Problem, problem, answer. Or if there's 3 numbers, problem, 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 answer. You should be able to connect them with a straight line all the way from the problem to the answer. Let's do an example of, let's write it horizontally. 8.2 plus 7.095. 8.2 plus 7.095. First, is that 0 important? Is that 0 right there important? Abby, why?
Because if you took the 0 out, then the 9 would be in the 10th place and not the 100th.
Yes, if I took that 0 out, it would shift the 9 to the 10th place and not the 100th place, which if we're talking money, that would be a difference of 9 cents or 90 cents. Is there a difference?
Yes.
Yes, okay, and it's not a huge difference, but there is a difference there, okay? So now, following our rules, it says line up the decimal points. So I write in my first number, 8.2. I write in my second number and line up my decimal points in a nice straight line. I'm going to go all the way down to my answer. What else should I do? Nate? What else should I do here? So we said line up the decimal points all the way to the answer. I have that. What's the second bullet point say? Okay, are they needed in this one?
Yes.
Where?
Above the 9 and the 5.
Yeah, I have to make them the same number of decimal places. And if with a pencil, I can do colors so you can see that they weren't there. In pencil, if you dot them in, that can be your way to show that they're not actually there. Okay, and then we just add 5, 9, 2, 5. I'd regroup, but it would just go right there. So 15.295. Okay, do we know any of the other rules yet? Maya, what other rule do we know? Subtract. This one's going to be easier to write. What is my rule for subtract? Maya? Okay, so it's the same as addition, except you subtract instead of add. Let's just write that. Same as, because there's an example box here, isn't there? Same as addition, except you subtract. And again, that's your biggest error when you get to subtraction problems is you line up the decimal points, you see a minus sign. A lot of times you even write a minus sign and then you add them together, okay? But that minus sign, no matter what math class you're in, that minus sign means subtract, unless it means a negative number, which is like subtraction. Then we're going to do an example there. Let's do 9 minus 4.76. 9 minus 4.76. Where do I put my decimal point if I don't see one? Because I'm supposed to line up my decimal points, but 9 does not have one. Brant?
After the 9 and 2 zeros.
Yeah, so after the 9 goes my decimal point. And you said add 2 zeros. Why do I have to add 2 zeros?
So it's so it has so it makes the number have the same amount of digits.
Yeah, so some people write it like this first, and then they add in their zeros, because I have to have the same number of digits. So I have 2 in that second number, so I need 2 in my first number. Why do you think I chose this problem as our subtraction example, Parker?
Because you have to regroup.
Because you have to regroup, and on the test, this is where our errors were, okay? If we did have mathematical errors and they weren't goofy errors, they were on this. So, can I take 6 away from nothing? No. So I have to go to the tenths, but there's nothing there, so I have to go all the way over to the ones. I'm going to take a 1 away from the 9 and make it 8. Where does that 1 whole go? Maya?
Right next to the
Yeah, right next to it in the tenths. How many dimes does it take to make 1 whole dollar? 10. That's why when we regroup, we bring over 10. Because from one place to the next, it takes 10 of those to make one of the next one. Okay, so this is 10. Can I leave it there? No, because I need to get some over here. So I'm going to regroup here. I don't have 10 dimes anymore. Now I only have 9 dimes. How many pennies make a dime? 10, okay? Like I said, every column, it takes 10 to get to the next one. So now this is a 10. What's 10 minus 6? 4. 9 minus 7? 8 minus 4? Is my answer 424.
no
Decimal point. Okay, so that's what we know right now. Today you guys are gonna tell me what the rule for multiply is, okay? Open your books to page 387. 387. We're not going to do a ton of modeling for this. The only modeling we're going to do is today. And it's so you can tell me what the rule is. Okay? You're going to tell me what the rule is by learning these models. Let me get to the top. Okay, so the problem is 0.3 or 3/10 times 2. Pull out your highlighter. Multiplication is the same thing as repeated what? Addition. Repeated addition. So that's what it's going to have us do here. It's going to have us shade 0.3 here. I want you to write this. And 0.3 here. First, how do I say that number? Maya? Okay, 0 and 3/10. How do I shade 3/10, Bryson?
3/10.
How do I shade 3/10 when there's 100 little boxes?
You shade 10 in. No.
Harper?
Shade 3 boxes in the first column.
That would be 3/100. Kendall?
You shade 3 of the.
Yeah, 3 sets of 10. So you'll shade, make my marker bigger. Okay, so you will shade 3 rows on this one, or 3 columns, sorry, because that's 3/10. And then you'll shade 3 columns on this one, because that's 3/10. And then it's wanting you to put both of those on this one together. So we would shade 3/10 and another 3/10. So how many columns should I have?
6.
I should have 6 columns shaded in on this one. So since we can use repeated addition, that way works. Shade 3/10, shade 3/10, shade them both together on the same picture. What is shaded? How much is shaded? Abby?
For this one or this one?
The total.
60
60 out of how many?
out of 100.
So how would I say that
60 over 100.
as a decimal?
0 and 6. 0.
Okay, so that's 60 hundredths. Do I have 60 hundredths shaded? What's up there that I don't really need though, Abby?
The 0.
The 0. So could I just say 6/10? Okay, now let's talk about that. We said we could have done repeated addition. Do we know how to add 0.3 2 times? Yeah, we do, right? Out to the side, let's show it. 0.3 plus 0.3 is 0.6. Did we get the same answer?
Yes.
Okay.
Mind blown.
I want you to try number 4 using that same strategy. I want you to do the shading, but then do the repeated addition out to the side. And notice here they give us 2 holes when we're shading, okay? You'll have to use both of those.
Plain noted.
Follow the same process.
You start with the first number?
What?
First number?
What do you mean the first number?
Like first number.
So can we shade 2 holes 7/10 times? Can we shade 7/10 2 times? Yes, so you'll be shading 7/10 in each box. So 7/10 here, 7/10 here, and then you're adding them together over on this side. Okay, so if you're stuck, your shading should look similar to what I have up here. And I did it in color so you can see where those boxes came from. Okay, I had 7 columns in the first one, shaded for 7/10. 7 columns in the second one to show 7/10. So the first 7 right here are from this one. and the second 7, which was split because I filled up the first one and then went on to the second one. So I have 1 whole filled, and what else? So I have 1 whole and 4 tenths or 40 hundredths. How do I write 1 whole and 4 tenths or 40 hundredths? Haley?
1 and then a decimal point and then 14.
Yeah. 1.4. Is that what you said? Okay. I could check that, check my repeated addition out here to the side. Did I get the same answer? Now, let's look at the problems and let's look at the answers to see if we can come up with a rule that may work. Because pretty soon both numbers are going to be decimals, and that's a little bit harder to model. It's not that it's impossible. So it's easier just to know the rule, okay? So we said 0.3 times 2 was 0.6. We said that 2 times 0.7 is 1.4. I will tell you a few more true statements, like, you don't have to write this, 0.4 times 0.2 is 0.08. 9 times 0.01 is 0.09. Does anybody notice anything? Even if you're not completely sure what's happening. Bryce, what's something you notice?
The 1 changed to a 9.
Okay, didn't change necessarily. Okay, but it has to be true for all of them. What's something that's true for all of them? Brant?
In the multiplication problem, it's 0.4, but on the answer, it's 0.0.
Okay, but is that true for all of them? We're trying to come up with a rule. There's a rule that applies for multiplication. Kendall?
You do mental math and add your zeros?
Okay, and it's not always mental math, but what do you mean by do your mental math?
Like you can do 3 times 2.
Yeah, so if she's kind of looking at the number without the decimal point. So here she sees 3 times 2 and she sees a 6. Here she sees 2 times 7, and what is 2 times 7? 14. And again, the answer is not 14, but do you see 14 in that answer? Okay. What about here? Ignoring the decimal points, what numbers do you see? 4 and 2, and do you see an 8 in the answer? Okay. 9 times 1 is? Do we see a 9 in the answer?
Yes.
So, go to your rule sheet. That is the first part of the rule. In a few better words. Let me clear this. Where's multiply? Bottom left?
Yeah.
Okay, so for multiplication, move this up a little bit. First thing you're going to do is ignore the decimal point. Okay, and you can't forget about them, but you can ignore them for a minute. So you kind of look past the decimal point. What do you think I'm going to write next? You ignore the decimal point, and then what, Harper?
Multiply the 2 denominators.
Yeah, you multiply the 2 numbers normal. Okay, this is why on that Are You Ready worksheet they had you practice your multiplication. Because you have to be able to do regular multiplication to be able to multiply decimals. Because really, we ignore the decimal point and we multiply like normal. Then we just have to figure out where to put the decimal point. Does anybody have any idea? Maya? So add and subtract. What's our 3 words that help us remember what to do? What's our 3 words, Abby?
Line up the decimals.
Line them up, and we're referring to the decimal points. The rule for multiplication is count them up, okay? Count them up, because you have to count the number of decimal places in the problem and make the answer match. And in parentheses, we're going to put start at far right. And again, that won't make sense till you see it. When you see it, you're like, oh, that makes sense. Okay, count the number of decimal places in the problem and make the answer match. Meaning, if there's 3 decimal places in the problem, your answer has to have 3 decimal places. Okay, if there's 6 decimals in the problem, 6 decimal places, how much does your answer need? 6. Flip your notes paper over to the back. Flip your notes paper over to the back. What I write over on that right side, you're writing on back. Split your paper in half. Split your paper, just write down that center hole, draw a line, and just write multiply examples. And again, this is on the back. I'm just putting it on this square so I have my rule right next to it. It doesn't matter which side. We're going to do divide examples on the other side when we get there. Okay, so let's go back to an easy one that we can do mentally. Okay, let's do 1.2 times 4. 1.2 times 4. Step 1 is ignore the decimal point. Dominic, if I'm ignoring that decimal point, what numbers do you see? 12 and 4. Haley, what is 12 times 4? Because it says multiply the 2 numbers normal. 48. So I would start by doing 12 times 4 is 48. Using estimating, what should my answer be close to? Lori?
50.
1.2 times 4? Kendall? 1.2 times 4. Abby?
4.
Should be close to 4 because we would round 1.2 to 1. 1 times 4 is 4. Okay? So to help us figure out our decimal point, it says count the number of decimals in the problem. You will underline them as you count. Looking at the problem, there is only 1 decimal place. So how many decimal places do I need in my answer, Bryson? 1, and it says start at the far right. So I go to the far right of the number. I put 1 line because I have 1 in the problem. I need 1 in my answer. So my answer is 4.8. I'm going to use those same numbers and change the problem, okay, just to show you how to count the decimal places. We know how to multiply. I'm showing you how to count the decimal places. I'm going to change this to 0.12 times 4. 0.12 times 4. Come on, Finley, catch up, please. Ignore the decimal points. Sophia, what math problem do you see if I ignore the decimal point? 12 times 4. What's 12 times 4, Soph? 48. So I still have the same math problem to start. Count the number of decimals in the problem and make the answer match. So I go up to my problem. I have 1, 2 decimal places. Do I have any decimal places in this number? Nope. So I have 2 decimal places in the problem. So how many do I need in my answer? 2. So I start at the far right. 1, 2. Where does my decimal point go, Kendall? Right in front of that. And what do you think I need to put in front of a decimal point if there's nothing there, Brant? A 0. Is the math the same? Yeah, it's just knowing where our decimal point goes. Now let's estimate that one. 0.12, what would you round that to?
0.10.
Estimating, guys, you're going to the nearest whole number. This was so easy last night, remember? 0. What's 0 times 4? 0. If you have 48 cents, are you close to having $0?
Yes.
Yes, so that answer makes sense. Same numbers, new problem. .12 times 0.4. Ignore the decimal points. Sadie, what numbers do you see? 12 times 4 is what, Sadie? 48. What do I do next? Haley? Count the number of decimal places in the whole problem, okay? So I always start on the left number. I have 1, 2 in that number, but I have a third one over here. So I have 1, 2, 3 decimal places in the problem. So how many do I need in my answer? 3. Where do I start? The far right. So I need 1, 2, 3. Where do I put my decimal point? Kendall? After that empty line. Bryce, what do you think goes in that empty line? A 0. What else do you think I need to add, Bryson? Another 0. Now, double check. I have 1, 2, 3 decimals in my problem. 1, 2, 3 decimals in my answer. Let's stop there, okay? Again, your homework tonight is not over this. It takes us a little bit of time to process this. Tomorrow, we're going to do a whole lot more examples with that, okay? But that's multiplication, the easiest way to do the multiplication. You do have homework tonight, but it is a review. In your book, flip back to page 383 and 384. Turn to page 384 real quick. 383 is just like last night's homework. On page 384, mark off 13, 14, 15. So you're only doing 1 through 12 on your homework, okay? So page 383, 384, 1 through 12. How do you know on a word problem if you're going to estimate? Kendall?
It says about.
It'll say about, or it'll say estimate, or there's one more word. Approximate, okay? This lesson is over estimating. So on problems 1 through 9, what are you doing? Estimating. Show your rounded problem and then your answer. So it's just like last night's homework. Okay?